This is a short follow-up video on EZ isomerism to accompany the previous video where I went into a more detailed explanation of how EZ isomerism occurs. This particular video is just to look at EZ isomerism related to alkene molecules without substituted groups like chlorines, hydroxyl groups, etc. attached to them. Just straightforward alkenes. So if you recollect, on the final video where we looked at this, I talked about two EZ isomers of but-2-ene. E-but-2-ene, where we have a trans configuration, and Z-but-2-ene, where we have a cis configuration. And again, to illustrate this, the best way is to look at a three-dimensional model. So firstly, let's look at E-but-2-ene. You can see that the 4 carbon atoms are actually in the trans configuration. We have the double bond, which is on carbon 2 to 3, hence but-2-ene. But-2-ene because it's a 4 carbon long compound. And you can see that carbon 1 and carbon 4 are actually opposite each other in the trans configuration, hence the E-but-2-ene and the trans isomer, because carbon 1 and carbon 4 are in the trans position, and I'm just illustrating that. So now if we look at the cis configuration, or Z-but-2-ene, with this three-dimensional diagram model, you can see again but-2-ene because the double bond is between the second and third carbon of a 4 carbon long compound, hence but-2-ene. But this time carbon 1 and carbon 4 are in the cis configuration. In other words, they're in that open U configuration that I described in the previous video. So this is Z-but-2-ene with carbon 1 and carbon 4 in the cis positions, as illustrated in this skeletal diagram. So I hope this short follow-up video helps to visualize and to construct EZ isomers for simple alkenes. Thanks.